All right, hey guys, this is our first note for Algebra 2. So go ahead and grab out your notebooks for me. In class, I showed you kind of what the example of the notebook is to be. If you haven't grabbed your notebook yet, go ahead and just get a piece of paper out to take these notes. Our notes are going to be very structured and kind of they look the same every time, so you can easily find them and so you can understand them. When taking notes, I recommend if I write something down, that you write it as well. You can always pause this video to write down what I wrote down. You can pause and copy the pictures more in depth, etc. So utilize the pause button. That is completely okay. So we're always going to start our notes with a title. So look at the very top of my page. My title is Evaluating Functions. So Evaluating Functions is our first title. If you want to, you can put Unit 1 by it because it's our first unit. But our first title is Evaluating Functions. I will always give you title at the very front. I usually highlight it or underline it so I know that that is what I'm focusing on. All right, from there, we're going to start our notes. Usually I have some type of outline. So if you notice on my page right now, I have some things in black that I already have written out. And then we're going to fill in the rest. So again, you'll have to pause the video to kind of write things down because I do have things already kind of started out here. So the first thing, what is a function? So we're talking about functions this first unit, so we have to figure out what it actually is. So a function is a relation where every element in the domain is paired with, this is a really key important thing here, exactly one element in the range. And highlight that exactly one. So essentially, if I read this out quicker for you, a function is a relation where every element in the domain is paired with exactly one element in the range. So what does that really mean? So I'm going to kind of use an example of a pop machine. So if I draw out my little machine here, here's my pop machine. All right. If I go to the pop, let's say I really want a Sprite. All right, I'm going to input, let's say, E5. And if I push E5, a Sprite will come out of the machine. Let's say my friend behind me also wants a Sprite. If they were to type in E5, they should get that Sprite. Now, what would happen if they type in E5 and they don't get a Sprite? It really wouldn't make sense, right? Because if you type in E5, if I got a Sprite, they should also get that same output. So for every input, you should have the exact same output. So it doesn't care on what we're kind of wanting there. If we put in the same amount or put in the same thing, it should be the exact same output each time. So for example, if I were to input, let's say like E5, and I'm going to get an output of whatever that E5 represents, that Sprite or Coke, whatever pop you want there. All right, and in our machine, that's what we call like the rule. That's where our function is. So like f of x is like our function. Okay, so in our functions, we're going to input a value, and usually our value is going to be our domain, and our domain is our x values. So we're inputting a domain value into our rule, into our pop machine, and when we put that domain in, every time we put that exact same value in, we should get the same output. All right, we're gonna get that same range value each time. So if I were to type in E5 a week later to that pop machine, I should still get a Sprite out of it. All right, it shouldn't be changing on me. All right, so that's what a function is. Now, we're going to move on to representing functions. There are 3 ways we're going to represent functions in this class. You've seen all of these before in other classes, probably in Algebra 1 or even back in middle school. They're just a little bit different. We're going to kind of make them more complex this year. So the first way we represent a function is what we call function notation. All function notation is the actual equation or like the actual problem there. So for example, what ours are going to look like, back in Algebra 1, you probably saw a lot of like y equals and some type of equation. We're going to step away from y equals. I'm going to focus on a little bit more of what we call function notation. So it looks like this. F of x equals 1/2 x squared minus 3x. So the right-hand side here should look this very similar to what you might have seen back in Algebra 1. It's just a plain old equation. The difference is instead of saying y equals, we now say f of x. Now each of these things represents something different. So for example, this f right here, that's our function name. We use f of x, g of x, h of x, k of x. You can use any letter, but usually those four are kind of like our go-tos. F of x and g of x are my personal go-tos. So that first letter tells you what your function is named. This x right here, that's your input. That's what we are plugging in to our rule or to our function or to our pop machine to figure out what we're going to get as our output. So everything over here is our output, or our rule, so our equation, our function there. All right, so again, we have our function name, you have your input, what you're plugging in, and what you're plugging in is always in that parenthesis there. And then the other side of the equation is actually your rule, or what you're going to get when you plug something in. This is going to be our most common way we're going to be representing functions for the good portion of a year. The second way is a graph. Okay, we will learn how to graph by hand and use graphing calculators. So we're going to draw two different graphs here. The first one's going to be an actual function. So here's our first function. Looks like a W. All right, so this is a function. The reason being it's actually going to pass the vertical line test. So I'm going to write down vertical line test. All right, and one of the vertical line tests, if I were to draw a vertical line on this graph, you'll notice it touches my graph right there in exactly one spot. So in order for it to be a function and to pass the vertical line test, when you draw on a vertical line, it will only cross the function once. I am going to show you an example of when it doesn't actually work out. So if I were to draw a circle, which you studied back in geometry, now, if I were to draw in that vertical line again, how many times does it cross this picture? Passes up here and down here. So it passes twice, so it fails the vertical line test. Therefore, it is not an actual function. All right, so graphs are easy. If you draw in a vertical line, it should pass once. And the third way we can represent a function is by a table. You probably studied a lot of tables back in Algebra 1. They usually had like an X column and a Y column. Now, if you remember back in our example number 1, we're not using Y anymore, we're using a function notation. So an example of a table could look like this. We have our X column, and we'll have, let's say, H of X. Okay, so if I were to plug in -2 to my X, for my input, my output, let's say, will be 4. If I were to plug in -1 for my input, let's say my output's going to be -5. If I plug in 0, it's going to be 1. All right, so a table will show that for every X value, it has a unique or exactly one Y value there. So what we're going to do is we're actually going to start evaluating it. So we're going to see different ways we can use our functions. So I'm going to show you all three of these representations in our problems. We're going to go there. So if you have a calculator, you may want to get one out if you don't want to do any mental math here. All right, so here, example, let's write this out. It says evaluate using the following functions. So when you see that word evaluate, that means they want you to plug in or utilize that input and figure out your output. That does not mean your answer is always going to be a number. It could be a variable, just depends on the situation. So for problem number 1, we're going to have two functions. We're going to have f of x and g of x. So f of x here, we're going to say f of x equals -x squared plus 3, and g of x equals 1 minus 2x. So these are just plain equations. All right, so our first problem says f of 3. So how we figure out these problems, you're going to look at what your function name is and figure out which of your functions you're going to utilize, and then you're going to look at what your input is. So in this problem, for problem A, it says f of 3. So our function name is 3, or so our function name is f, so we're going to be using the first equation up here, that -x squared plus 3. Then you're going to look at what our input value is, and our input's always in the parentheses. So if you look at this parentheses, we are plugging in or inputting 3. And what that means is when you look at your original function or your original original equation. Instead of x, you're now going to replace every single x you see with whatever your new input is. And in our instance, it's 3. Okay, when we plug something in, you're going to want to use parentheses. So for example, if I see this problem, I've got negative x squared plus 3. So negative x squared, so I'm going to plug in my parentheses, and my x value here is 3 squared plus 3. Okay, so all I did there, instead of my x value, I replaced it with what my input value is. Now what I like to say, we're going to do the math. We're going to simplify it and make it look prettier, better. So we're going to do parentheses first. So 3 squared. Squared, all of a square is, it means you multiply it by itself twice. So what's 3 times 3? 9. So I have negative parentheses 9 plus 3. I can distribute that negative into that 9 there, so it'd be negative 9 plus 3, which would equal negative 6. And that's your problem. Okay. Problem number 2, all right, or problem B is g of 3a. All right, so our function is g, so we're going to be using that 1 minus 2x. In this instance, though, you gotta look at what our input value is. So now our input is 3a. So every time we see an x, we're gonna replace it with 3a. So my g function is 1 minus 2x. But instead of x, we're gonna use our parentheses and plug in 3a. We're gonna do some math here. 2 times 3a is 6a. And then you're gonna see, can you combine those terms? And your answer is no, they're not like terms. You have 1 and 6a, so that would be your final answer. So if you notice, our first problem here, we just plugged in a number, and we got a number as our solution. The second problem, we plugged in a number and a variable. All right, so we do have both a number and a variable left over in our equation there. So depending on what you plug in is what type of answer you're going to get in return. All right, letter C, f of a plus 1. So this is our f function. Our input now is a plus 1. So instead of that x, I'm going to plug in a plus 1. So I've got negative parentheses a plus 1 squared plus 3. Now remember, that squared is important. That means you multiply it by itself twice. So I do want you guys to get the habit of writing it out twice. So I would write out negative parentheses a plus 1 parentheses a plus 1, because squaring means you just multiply it by itself, plus 3. If you notice here, what we're going to have to do is what we call double distributing or foiling, depending on what you learned. All right, so we're going to FOIL that a plus 1 times a plus 1. So I'm going to do a times a, which is a squared, a times 1, which is a, 1 times a, and 1 times 1 is 1. Now that I have that, I can distribute that negative through. Remembering the negative doesn't go to the first term, it goes to everything in that parenthesis. So that would then become negative a squared minus a minus 1 plus 3. And from here, we're going to combine some like terms. I see that negative a and negative a are like terms, and the negative 1 and the 3 are like terms. One thing I do want you guys to get in the habit of is when we write out, I do want you kind of writing out in decreasing order here if you have multiple a values with different exponents. So I would say my final answer would be negative a squared minus 2a plus 2. All right, our last problem is a little bit unique here, and you'll see some more in our practice when we do in class. So it says g of x equals 10. So as opposed to all the other ones here, we actually have an equation as our problem here. So we're using our g function. Our input is x, so we keep it the same, and it says equals 10. So instead of giving us our input value here, they actually gave us our output. Okay, so all the other problems, they tell us what we're plugging in. They're no longer telling us what they're plugging in. We don't know what x is. They're telling us if we were to plug in some x value, your answer is going to be 10. So what we do is g of x. Do we know what g of x equals? Yeah, g of x is negative or 1 minus 2x. So I can say g of x is 1 minus 2x. And we know that it equals 10. Does that look like a problem we can solve? Yeah, basic algebra 1 problem here. We're going to subtract 1 from both sides. We're going to divide by negative 2 on both sides. And we get that x is negative 9/2. You can put that as a decimal as well. I'm kind of flexible on what you do as your answers there. Okay, so those are some type of problems you're going to see. That was all of our representation of like our function notation. Let's look at two different other types of notations we could utilize. All right, so another notation we could use, all right, we're gonna do a table and we're gonna do a graph. So I want you guys to draw these with me. So we're gonna make a table. So we're gonna have X, here are columns here. Let's call this H of X. All right, I'm gonna say if I plug in -2, I get 4. If I plug in -1, I get 7, 0, 10, 1, 13, and 2 and 16. All right, there's H of X. And then we're gonna draw a graph. Now, it's not gonna be the prettiest graph, we don't have graph paper, but we're gonna try our best here. So I'm gonna draw my graph. We're gonna draw a straight line. I'm gonna kind of pick the points here to draw our line through. So I'm gonna do 0, 1, 2, 3, 4, 5. 0, 5 is going to be a point. 1, 2 is going to be a point. Or -1, 2 is going to be a point, and then -2, -1 is going to be a point. All right, and we're gonna call this one K of X. So again, if you need to pause the video now and write those down, that's totally fine, you can do that. All right, so our first problem here, this one looks a little different. It says H of K of -1. So when you see a problem like this, we're gonna start from the inside and kind of work our way out. So look at the inside here, it says K of -1. So we have to figure out what K of -1 is. So we're going to look at our graph here. K of -1, K is our graph here. If I go to where X is -1, on my graph, that is this point right here. And what is our output there if I plug in -1? My output's 2. So instead of K of -1, I'm going to replace that with 2. Keep my H out there. Good. All right, so I figure out what K of -1 is, use that function, and I put what I got as my answer there. So now, instead of 2 functions, we have 1 function. So this is H of 2. All right, our H function is our table. So you have to look at your X values where we plug in 2. Okay, so I plug in 2 for X right here. What is my output when I plug in 2? It's 16. So my answer would be 16. Awesome. All right, this one over here, we've got 2 different problems here. We have H of -1 times K of 0. So what I do here is I kind of break them apart. So I'm going to do the first problem here, K of -1 first. Then I'm going to do the I'm going to do H of -1 first, and then I'm going to do the K of 0 next. So H of -1. H of -1 is my table, so look at my table, and I'm going to figure out when X is -1. X is -1 right here, and my output there is 7. Okay, now to do K of 0. All right, K is my graph. So I look at my graph when X equals 0. All right, my output is 5. And so now our problem is simply 7 times 5. 7 times 5 is 35. Okay, so you can look at a problem and kind of split it up if you need to. Same with this problem, we're going to split it up here. So we've got H of 0 minus K of -2. So we're going to do it part by part here. So we're going to do H of 0 first. H of 0, H is our table, so look at when you input 0, what's our output? It's 10 minus, all right, when we do this one, K of -2. So looking at my graph, when X is -2, all right, my output, it looks like is -1. So now we have 10 minus a -1, which is just 10 plus 1, which is just 11. Perfect. So if you have any questions about this, I would maybe like put a star next to any of these or things that you don't quite understand and ask those tomorrow or whenever I see you next in class. You can kind of keep a running list of not quite sure about this or you want me to go over it one more time. See you guys later.